let's get started here. Obviously, we lose a little bit of time here today with the shortened schedule or whatever. I'm going to try to do a little bit of everything still. So, let's finish up talking about this final free response question. Take some review questions from you guys. Maybe talk a little bit about 7-1 and just do the best we can with the time we got. Sound good? All right. So we're in the midst of this when I ran out of time here. So we had, we were looking at this problem, and I was talking about the AP scoring for this and how that was going to work. Let me find my page. There it is with all the scoring. So this one you had 1 point for the limits of integration. You had 1 point for the setup, whether you set it up this way or that way. And then the answer was 1 point. And again, this one could have been done two ways. You could have integrated with respect to x by breaking it into two integrals, or you could have used one integral and integrated with respect to y. That's probably what I would have done, but it's not incorrect to do, to do the x. It's really not any more work other than you have to do two integrals on your calculator, but whoop-de-doo. And to actually do the integration, this is a calculator problem, so you're just typing it into your calculator and pressing enter, right? You're not actually doing anything by hand here. Part B sounds trickier than it really is. So it says region R is the base of a solid. For each cross-section perpendicular to the x-axis is a square. Write but do not evaluate an expression involving one or more integrals that gives the volume of the solid. So basically, if I cut a cross-section here, that distance would be a side length for a square, right? Everybody agree with that? That's what the directions are saying. Each cross-section perpendicular to the x-axis is a square. So that cross-section that I've drawn is the side length for the square. Everybody agree with that? So when I set up my integral then, I'm going to use two integrals because the side length is going to change after you hit the intersection of the two functions. Everybody's good with that? So it'll start as 0 to 369, and then it was natural log x dx, and then 369 to 5, and the other function is 5 minus x dx. But that's just the side length for the square, right? What's the area for a square? Yeah, side length squared. So each of those should be squared. And then that should give us our answer. It's just typing into your calculator at that point. So we have 1 point for the final answer. And then you have 1 point for this integrand and 1 point for that integrand. And it's not this set of instructions I have for the grading is not super specific. I would almost wager that if you have this part correct, that's probably 1 point, and the limits is probably 1 point. But I don't have enough details on the guidelines that I found for this problem to tell you exactly where those 2 points are coming. But that's the idea. So again, if you read this and you try to picture this, it's really stinking difficult, right? It's kind of like a red herring. You don't actually need to picture squat. It's telling you, the shape for the cross section, and then it's telling you that like how to find the segment that you need to your area formula, and then you just integrate. And I've seen a bunch of questions phrased in this fashion on these AP free response questions, where seems a common question phrasing, and it sounds really difficult and complicated, but they're telling you everything you need inside of the problem. I thought that C is actually the trickiest part of all between the two questions for all of this. So C says a horizontal line y equals k divides this thing into two regions of equal area. Let me recopy that in there. Write but do not solve an equation involving one or more integrals whose solution gives the value for k. So let's say that this is y equals k here. I'll call this part R1 and this part R2. Everybody agree with that? So what you want is you want R1 to equal R2, correct? Looking at this, do you want to integrate with respect to x or y? I would do y as well, because that way I can use just one integral for like this region and then one integral for this region. Everybody agree with that? Or what else could you do? That would be okay, what we just described. Well, you could do dx also. I think that gets messy, though. Or you could set it up this way, right? The integral from 0 to k should be half of the whole thing. That, I think, is probably the easiest setup, since we've already done this part, right? We did this in part A. That's why I'd probably choose to go that route. So what is that then? Oops. So we have the integral from 0 to k, and then I'm just going to use the same setup I used for part A. Or even here, you could have used, what is it? It's like 2986 was your answer from part A. You could have used that there even. I think that would have been okay. So reading this, you have 1 point for the limit, 1 point for this, and then like 1 point that it's equal to something that's true, right? That'll give you the answer for k. Notice this one again says write but do not solve. So you didn't actually have to do anything after this. You just had to set it up. Alternatively, you could have gone like 0 to k, 5 minus y minus e to the y dy equals k to 131, 5 minus y minus e to the y dy. That would be valid, right? You could set it up that way. That's okay.
And is that just it?
Yep. That would have been okay. That's kind of what we discussed earlier, right? Initially, just the area of the first integral has to equal the area, or area of the first region has to equal the area of the upper region.
How would you solve? Like, I don't didn't ask that, but how would you solve that for K?
So you do the antiderivative, you plug in the bounds, and then they're equal to each other, and you just have to solve the K. It's going to stink because you have an exponential and a linear together. You're going to you'd have to use your calculator to do it, to find the intersection, but that's all you would do. And you'd have to do the antiderivative and plugging things in without your calculator because you don't have symbolic algebra on your calculator, so you can't plug the K in. Or if you wanted to do x's, so you do 0 to, what was it? It's 369, I think, was the end of k minus, right, 369, okay, of k minus the first stuff, and that was the exponent, or the logarithmic piece. Dx has to equal, or plus, 369 to 5 k minus the linear piece, and that would have to equal the reverse of these, so ln x minus k dx plus to 5, and then 5 minus x minus k dx. I think that would count as well. You could have set it up that way, going with respect to x. So you're taking the stuff under k and then the stuff above k. And I think that would work as well. Again, I think that's a lot more to kind of make sure you got than doing it with respect to y, but I think it would work. We'll continue to do some more practice on these things as we're getting closer to the end. I'll start circulating in some more AP practice. The hope is that all of April will be done with content by April and can spend that whole month kind of just doing some practice and reviewing and sneaking in some of these extra BC-ish topics that I'd like to do. But that's my plan. Let's, do you guys got some questions from homeworks or the review that you guys want to talk about? Change gears here a little bit. Blake?
Would you mind taking a look at number 10 on the review?
10 from the review? Sure. All right, so part A, we know that f_av is going to be 1 over pi minus 0, the integral from 0 to pi of sine 2x plus cosine 2x dx. Good with that? Okay, so let's just use our, I'm going to just use our calculator to do this. I guess it doesn't tell us to use the calculator to do this. Okay, so let's do it by hand, I suppose. To do the antiderivative of sine 2x, what do I need to use? Yeah, you should do a u sub. So du over 2 is going to equal dx. So I have 1/2, and then the antiderivative of sine is negative cosine. And then I'm going to just put the 2x's back in. And then the same thing over here. The antiderivative of cosine is sine, right? And we're evaluating from 0 to pi. So far, so good? Okay. So cosine of 2 pi is 1, right? So negative 1. Sine of 2 pi is 0. Cosine of 0 is negative 1. Sine of 0 is 0. So what do I get here? I get 1 over pi times negative 1/2 plus 0 plus 1/2 plus 0. So we get 0 here. Is that okay?
Yeah,
okay. Is that what I had on the key?
Yeah.
No. Okay. Splendid. Did you do it on your calculator to double check?
No.
Okay, let's just do that real quick. Right, before we decide that Mr. Kulik just made the same mistake that you guys made or something. I'm going to skip the 1 over pi in the front because it doesn't really matter. Sine 2x. If it's 0 anyways, right? That's not affecting anything. Sine 2x dx. Okay, what's that?
0.
Basically 0, right? Why is it not giving me exactly 0? Because it's an approximation, not an exact. Yep, good. If you have a CAS calculator, it probably gives you exactly 0. But our CAS brothers aren't here to check for us. So I think that's right. Did I say it was that this was 1? I goofed a negative sign probably or something. Yeah, probably. That sounds like a Mr. Kulik mistake. All right, so then to do part B, I'm just going to do cosine 2x plus sine 2x. And graph that from 0 to pi. And probably just need to go from -2 to +2. And let's see where we got zeros at. So I have one answer here and one answer there, right? I think we could probably even find these algebraically, realistically, if we wanted to. I'm just going to find one of them and just, after that, you guys get the point, right? We'll go back and fix the answer key in just a second. So 117 or 118. And then the other one would have been, I'm glad you guys keep catching all my mistakes. It's discouraging for me that I keep making them, but I am super glad that you guys are like trying that hard and not just like 275, like letting it go. Is that what you got also? Okay. Okay. Fair enough. How would you do this algebraically if you wanted to try to do algebraically?
Like solve for x.
I would subtract sine 2x to both sides, divide both sides by cosine 2x to turn that into tan 2x equals 1, or negative tan 2x equals 1, so tan x equals negative 1, or tan 2x equals negative 1, and then you could tan inverse both sides and go from there. Standard solving trig. Should be able to do it, but I don't think that you would. I don't think you would need to do it by hand. I'm just pointing out that we could have. Specifically says part B. No. I haven't seen anything on an AP exam where you'd had to have done something like that by hand.
Okay.
And I would not ask you in class to do something by hand like that, but your college professor might expect you to do that by hand. I'm just pointing out that you could. Mackenzie.
Can you do number 6 on the review?
6 from the review? Sure, hope so. All right, find the volume of the solid by rotating the region bounded by the curves, yada, 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 and y equals 1 and y equals 3. Okay. Well, let's start by just generating a picture here so we can have some idea what we're looking at. Y equals, was it 1 minus x squared? And then y equals x squared minus 1, and then it was 1 and y equals 1. Okay. I guess we really didn't probably need that. About the line y equals 3. Oops. I'll make that dashed. So drop that in here for us. Not make it so it's stupidly huge. All right. So we're looking at that region there, right? Oh, that's not right. Nope. I did 1 minus x squared instead of 2 minus x squared. Okay. I'll show you in a second. Yep. Come on. That's good enough. Okay. So if I want the region bounded between those two curves, n y equals 1, we're talking about this region here. Now, why did I do this? Why didn't I just do the region between the two curves? Doing it this way really forces you to integrate with respect to y. Will make it massively easier than trying to integrate with respect to x. If you wanted to integrate with respect to x, how many integrals would you need? 3, right? You'd need one from here to here, one from there to there, and then one from there to there, which stinks. If you do integrate with respect to y, though, you just have one thing. Anyways, let's go ahead and we're rotating about this. Right? So, oh, we would want, I guess we would want these distances though, huh? Oops. Right, this will be washer shaped because it's like this and then it goes like that or something where it just flattens out in the middle, right? Oh, the other side, it's not symmetric though, right? It's like this. Or it's, I should say it's like that or something. It's weird looking, right? Something like that. Okay. Oh, did I not have that on the review? Maybe. Well, let's look at the key, right? Yeah. No, this is, look, it's very possible, like, as I was doing this, I'm like, oh, this, like, I need to edit this. And then I just, like I write the question, then I do it. And as I'm doing it, I'm like, oh, this is way worse than I want it to be. Let me edit this. And then probably just forgot to go back and change it kind of thing. So let's look real quick. Which is a totally fair question for you to ask, Mackenzie. Like, absolutely be nitpicky about it. Like, hey, it seems like you did a different question or something. Which is, like, matters, right? All right, 6. That's chapter 5, dummy. What are you doing? Okay. Yeah, so I didn't do that. So this must have I just must have forgot to change it out when I was doing this.
So the y equal form would be this.
Yeah. Yeah. That's my fault. And we could do it still, but it's gonna like stink.
So we're getting rid of the y equals 1.
Yeah.
Okay, classic.
You have to do 3 integrals.
For the inside.
The inside radius is gonna be different in 3 places though, right? Right, like here the inside radius goes to there, here the inside radius goes to there, and here the inside radius goes to that curve, right? So you would need 3 integrals like we were talking about before if you had to integrate with respect to x. Well, like it's going to be a washer, right? The outer radius is constant the whole time. That's true. But the inner radius is changing. It changes from one function to the horizontal line back to the first function again. You know what I'm saying, Mia? We did. I thought you were saying, oh, what if we do? No. If the horizontal line's not there, then yes, it's just one thing. It's pretty straightforward. It's what's on the key, I think, should be right. I thought you were saying, can we still do it with the horizontal line? Because I spent a bunch of time doing it, and I wanted to see how it went. Okay. Yes, yeah, I misunderstood what we were saying. So if that's the case, Mackenzie, you're good?
Okay.
Or no?
No, I'm good. I understand it now. I was just a little confused.
Yeah, no, you should have been. You should have been when you looked at my answer and been like, yeah, what happened here?
And then also 7.
Uh-huh.
Can we do that?
Again, I sure hope so. You think it's wrong? Oh, no. All right. All right, let's see here. I kind of wish the default was like no grid. Okay. Okay. So that's enough there. Okay. So we're looking at this region here between the two curves, the x-axis, or the two horizontal lines, the x-axis and the curve, right? And we're rotating about the y-axis. I'm sorry, the y-axis. Come on, dum-dum. So what's this thing going to look like? It's going to look like a solid like this, right? So I think we can just integrate with respect to y from 1 to 2, and then we just need this distance is the radius for my disk, correct? Okay. So to get that in terms of x, we'll subtract 1 over. We'll do the e to the both sides, and then we'll add 1 over. So that's x. That should be my volume there. Is that what I did? Oh, did I?
Yeah, it was like a -1 square.
Oh, yeah, because I had. Okay. Yeah. So here's what I had. If I look at the picture, Mackenzie, I had like. I also had it bounded by x minus 1 or x equals 1. So I had like a washer problem when I drew the picture.
Okay.
So like if you did the problem I had, then the setup, what we had was fine. If you do what I drew, you need to use a washer where the outer radius is what we had there, and our inner radius would just be that, right? You know what I mean? So I don't know. I guess I need to stop editing and writing the key at the same time. That's the moral of the story. Does that feel okay? So thank you again for catching what's going on here. I think what we'll do, just so that the answer matches the key, is we'll do that. So the answer matches the key. It's probably easier for me to edit that than to rewrite the key, right? The picture?
Yeah.
Yeah.
I just put this into the calculator and I got like the answer, but last night when I did it, I just didn't get that. So.
You want to look at this thing again?
Yeah.
So the green is not.
Maybe if I just did the algebra wrong or something like that. Yeah, never mind.
Okay.
Flip the sign. Flip the sign gave me something that was a couple orders of magnitude off.
Yeah. Fair enough. That happens. It's a punishing course in that regard, where it's like the little mistakes just like screw everything up.
It adds up, man. Could you do me a favor?
Yeah.
Could you go onto the answer key just real quick and look at question number 3? I just want to see if I. That one also, the question was written, so if you look at the first integral, the question was written square root of 4x squared plus 20x minus 99.
Ah. Yep.
So I got.
So if that's the case, that's much easier. So let's.
I think it might not have been.
No, it's totally fine question. Let's grab that, because if that's the case, yeah, I think I must have changed this because I got done doing that and that stunk. So here's the dealio. This is a much easier problem because I can write this by adding 1 and subtracting 1. This is a perfect square. So I know that like a minus b squared is a squared minus 2ab plus b squared. So a should be 2x, b should be negative 10, or well, really just 10 since I wrote the subtraction symbol there already. And I notice that 2 times 2x times 10 does give me 40. That done. Square completed.
Yep.
Massively easier than the problem that I'd given you with the negative 29 in there.
Yeah, because if you take the 12 out, that's like sine 2x minus 10. If you did it anti-derivative.
Well, close. Because you have to do a u sub, so you have a factor 2 rattling around in there also, right?
Oh, yeah.
So u is 2x minus 10. So du over 2 is going to be dx. So it'll drop down to 6 sine inverse of 2x minus 10. And that's a much easier problem than what I had written there. Because you don't have to worry about like the yucky factoring going on. Right? What did I have to do here? I had to take that 4 out and like you got a fraction and add factors of 4 in there now and like it got gross. Yeah. And you had to factor that 4 out and that comes out front before you can get it in that form. It was just yucky. Mia.
Oh, sorry.
I think so. Are we done with this, Blake?
Yeah, I'm good.
Okay.
Did you get to 5?
5?
Just like the setup is.
Yeah, sure. Okay. Notice all these were pretty nice ones that you could get into your calculator, right? Even if I wrote them like not as y equals, they were still pretty pretty reasonable. So you have this thing. Well, I guess y squared minus equals 1 minus x is not lovely. And then y equals 0. Yeah, zoom into that a couple of times. Okay. So we're looking for this region, right? So you could do this 2 ways. You could integrate with respect to x or y. I think in my key I probably did y's.
Yeah.
So my y's go just from 0 to 1. I can just tell that from looking at it, right? So I'll do the, I need this distance, which is the curve on the left, which was the quadratic one in terms of x, minus the curve on the right, which is the cubic one.
So it's right minus left.
Yeah. And that ought to do it. You could
It would be 1 minus y squared.
getting the x by itself. Oh, sure. Thank you, Blake.
How would you just solve that?
Well, in this one, it doesn't even. I don't even ask you to just plug in your calculator, right? Do the setup, plug it in. But yes, you could do that by hand. Certainly, that's not a difficult integral to do by hand. But I'm just looking for ways to save you some time. Well, because that distance is an x distance. It's horizontal, right? No, because this x is a negative value. So when I subtract that side, it's like adding. Yep. So we'll worry about 7-1 later. Don't worry about it today. Thanks, dude.
Thank you.